Okay, we'll continue then. Yeah, okay. Right, we'll start the next lesson now. So, earlier we did exponential equations, so now we're going to do equations with logs, but not only equations with logs, equations that need log to solve them. So, just to start with some basic ideas first. So suppose I had something like log, 4, 2x plus 1 equals whatever, 10, and we're looking for x. The first thing you must remember about logs is that we can't use any value in here. Do you remember that log, you can only put into logs positive numbers. We can't even put 0 in, or we can't put negative numbers in. Okay? So the first type of question that you might be asked is, when is this defined? So we want to know basically what are the possible answers for x, but we're not going to find x just yet. So this can only be solved if 2x plus 1 is greater than 0. Because we cannot have it less than 0, we can't have it equal to 0. So this means x must be bigger than minus a half. Now, is that okay? Yeah. Before you start a question with logs, it's good to write down what the answer should be in. So here the answer should be in the set all numbers bigger than minus a half. So if you got an answer that wasn't like this, then we can't use that answer. Okay, so our answer we get must be bigger than minus a half. So let's have a look at a simple equation before we start. So the first one, log, so this is like our first example, log 5x equals 4. So before I start, what do I know about the x? It has to be greater than 0. Okay, now this one there isn't really anything to do to solve it. You just have to think about what's happening. So here we have 5 to power 4 equal to x, because you just have to remember what logs represent. What you're saying is 5 to the power of 4 equals x. When you write log bx, you're saying b to the power of whatever's here equals x. The log goes this way around. So 5 to the power of 4 equals x is another way just to write this exact same thing. So, well, that's it for x. It's 5 power 4. And I mean, that's not really the type that you get in the exam. So let's have a look at some real examples that you would get in the exam. So for the moment we'll step away from having log in the equation, and I'll just write 4 power x equal to 9. So in the last lesson, the way we were able to do this is by rewriting the 4 and the 9. But we can't do that here because we cannot make, well, I mean, you could make 4 equal to 2 squared, and you could make 9 equal to 3 squared, but that's no good because we needed the same number. So we can't do it this way. But we can use logs. What we can do is we can put a log on both sides. We can say log 4 power x equals log 9. So basically, if you have a equals b, you can say log of a equals log of b.
Did you just do ln
ln is log. Natural log, yeah. Yeah. The reason I'm using natural log is because no matter what calculator you have, you'll have natural log on it. Yeah. Okay, now we can use the rule of logs that says powers can come down to the front. What was that? The third rule or something like that. So here we get x log 4 equals log 9. So x equals log 9 over log 4. And that will equal 1.585. Now you can test that this is the right answer. If you put in 4 power 1.585, you should get roughly 9. Yeah. So we can use logs to find the power here. So this gives us actually another way to solve these, other than the way we saw in the first class. But the advantage for this method is that it always works, because you don't need the 4 and the 9 to simplify. Okay, I'll give you one like this to try. So try this one. 6 power x equals 3. Give me the power for x. Do you need to write the last one down?
Do we have to include that is equal sign? Do we have to include the equal sign or just find the x in the last one?
For the last one, you can stop here. Yeah. Yeah, let's have a look here. So this will be log 6x equals log 3. X log 6 equals log 3. So x equals log 3 over log 6, which is 0.6. Yeah. 0.613. Yeah. 1. Yeah.
Can't you solve it?
Yeah, that's what I'm about to say.
Yeah,
So,
I think wrong. 3 basics.
Yeah. The other way you can solve it is if you have 6 power x equals 3, you remember by definition you're saying 6 to what power equals 3, and this is what log is for, remember. So you could say log
3 basics.
6 3. 6 to what power makes 3, and you should get the exact same answer. Log 6 3, and I get the exact same answer. Yeah. Now that works fine here, but I have a feeling that in the exam they kind of expect students to do it this way, but you should still get the marks if you do it this way. It's no big deal. Just make sure it's clear that you write in the, don't just jump to the answer, write in, log 6 3 equals the answer. Just make it clear you're doing it this way. Okay. Right, let's go down to another one now. Can I scroll down? Yeah. Okay, I'll give you another one to try that's very, very similar to this one. It's 6 power x minus 4 equals 9 power 3x plus 7. Give this one a try and then I'll do it. Finished? Yeah. Yeah. No. Let's have a look at it. So actually you do it the same way. You put log on both sides. So there's a log here and there's a log here. But the power is just a little bit bigger. So now we have x minus 4 comes down. Log 6 equals 3x plus 7 log 9. Yeah. Now, we multiply this in, and we multiply this in. So we get log 6 times x minus 4 log 6 equals 3 log 9 times x plus 7 log 9. We'll put the x's on the left. Log x6 minus 3 log 9x equals 4 log 6 plus 7 log 9. I should actually say that the last question you could get in the exam, but it's a little bit too easy. This is a very common type of exam question, the one I'm doing now. Okay, so you can see that x is in common to both, so we can take the x out, and we get log 6 minus 3 log 9 x equals 4 log 6 plus 7 log 9, and you realize there's only one step left, and that's to divide. So the last step then is x equals 4 log 6 plus 7 log 9 over log 6 minus 3 log 9. And often they want the answer like this, but not always. So if they say exact answer, you can leave it like this. But as a decimal, 4 log 6 plus 7 log 9 over log 6 minus 3 log 9. So this is 1.711. Very common exam question. Very common. Okay, do you have this one written down? Not yet, no. What did you type? You mistyped on the top line. It's 7 log 9. Have a look at what you typed. This one here. Okay, continue. Continue. Yeah. Okay. Scrolling down. Right. The next thing I want to show you is a useful way to rewrite expressions. This here is 2 with a power, and it doesn't matter if it's 2 or 3 or what the power is here. You can always rewrite these in the form of a, e, b, x. Now, the reason you may want to rewrite it, I wonder if anyone knows, why might you want to rewrite this in this form? To what? Graphing it, yeah. So if you wrote it like this, it'd be easier to graph. Any other reasons? Well, maybe it might be more useful if you only had natural log on your calculator. What else? And for those people who've studied calculus before, it's because this has a derivative, but this one, it's not clear. So there's a couple of reasons why you might want to rewrite it. So I'll show you how to rewrite it then. So our goal is to try and finish here, at this one. And just before we started, just a couple of points that might be useful in case you didn't know, because I haven't actually said it yet. If you have, for example, log, let's say, log ex, that's the same as log base e, ex, which is the same as x. Because e to what power makes e power x? Well, the answer, of course, is x. So basically my point is natural log and e can cancel just to leave x. So natural log and e can cancel to make x. But the opposite is also true by the same logic. E and natural log together can cancel to make x. So this might be, if you didn't know, you might want to write it down, that log cancels e and e cancels log. Yeah. Does anybody know what the word is to describe something which cancels some other function? Yeah, we say that the log is the inverse of e and that e is the inverse of log. Inverse. Inverse. This is a word we'll use again later, don't worry. We don't need it right now. Okay. If I can go back then. Yeah.
Why I understood the second part. The first part when you said log e, no, that's first the other one.
This one? Up here?
I don't understand it.
Yeah, log ex equals log base e ex. Is this part okay or not?
Yeah.
Yeah. So e to what power makes e power x? E to what power makes e power x? Well, x.
Yeah.
So the answer is x. So my point is log e and e can cancel basically. You're just left with the x that you started with. Yeah. Okay, back over here. So we're trying to rewrite this. Well, the first thing I can do is I can at least separate it as 2 power 4, 2 power 3x like this. So this is 2, 4, 8, 16 times 2 power 3x. So this is not so bad. I mean, we're trying to get to a, e, b, x. So I kind of feel like I have the a already. What's the a going to be? It's probably going to be 16, yeah. So let's see if we can get the e part to appear. Let me see. What will I do? I'll do 16 Now what I would like is to have an E here, but I don't have an E. So if I put in an E, I'll have to put in a log as well so that they cancel. Because I can't just put in an E, I have to put in something to cancel it. So E and log, what happens? They cancel. So it's okay to put in E and log. And here will be the original 2 power 3x. Yeah. Oh, Pinkies have the wrong room. Now I know this is looking pretty big here because it's e to the power of log of 2 to the power of 3x. So we can simplify this. This 3x here can come down in front of the log, yeah. So we can write this as 16 times e 3x log 2. Or, a little bit neater, would be 16 e power 3 log 2 x. Now you realise I'm very, very close to what I want because I have AEBX. So if I just get my calculator and type in 3 log 2, I get 16 e power 2.0794 x. So what I've just done is I've taken this and I've rewritten it in this form. Now just to prove that it's the same, or not prove, but rather convince, let's pick a value for x. So let's just say x equals, let's just say 1. So what will this equal? 2 power 3 plus 4, which is 2 power 7, which is 2, 4, 8, 16, 32, 6, 128, is it? Right, so I get 128 if I use this. Now I'll take this one, and likewise I'll put in 1. So I have 16 e power 2.0794 times 1.
127.99.
Yeah, 127.99, is it? So if I round that off to 3 significant figures, it'll be 128. So that's there, that's that one, for example, and here in red, that's that one there. So they're nearly the same. In fact, the reason they're not the same is because here I had to round off. If you want to keep it more exact, you could leave your answer in this form, which is actually a little bit better. Okay. So we've done it here. The A is 16 and the B is about 2.0794. I have one more example to do, and then we'll have a talk about the coursework. Yeah?
What's the question?
The question is rewrite this in the form AEBX. Now, you don't really get questions like this in the exam. What I mean is in the exam they won't say rewrite this as this, but rather for other problems later we'll find that it's easier to do it if we do rewrite it. Okay, so this wouldn't be an exam question by itself, rather this would be part of a technique for dealing with a more difficult exam question. Okay, so this is quite a useful thing to be able to do, to rewrite it in this form. Okay, can I scroll down? Yeah, okay, so I'll do one and then I'll let you try one. So we'll have a couple of log equations. So we'll have log base x of 2 minus log base 2 of x equals 3, and we want to solve this for x. So what's the first thing I should do here? And before that?
Change base.
Before that? Before that? Before that?
Rewrite the log equation.
Before that? Before that? Before that? Huh? Write the final answer?
Take out log.
I would love if I could do that. No. No. The very first thing I should do is I should check what values of x I can use when it's defined. Yeah. So here is really the problem. What do I need for x? I require or I need x to be positive, okay? Okay. I kind of thought that's what you meant when you said it, yeah. No, seriously, I did think that's what you meant, yeah. So not the final answer, Torquay, but rather we'll say what values of x I can use in the final answer, yes. So you're the only one that was listening to me earlier, good. Right, so here we need the x to be positive. Now we can start to solve it. Yeah. Alright, so now what could we do to solve it? Well, a lot of people notice the problem here is with the base. Here's an x and here's a 2. So the first thing I'll do is I'll change the base. I think it's rule number 5 or something. I'll swap, it's rule 4, isn't it? I'll swap these two. So this will be 1 over log 2x minus log 2x equals 3. This time I will use a substitution to make it extra clear. We'll say let u equal log 2x. So this will be 1 over u minus u equals 3. Okay, what do I do now to continue? Multiply by u, so I'll get 1 minus u squared equals 3u. So I'll get u squared plus 3u minus 1 equals 0. Here's u here. Log 2x. So here, log 2x and log 2x I replaced with u and u. Yeah. Now, does this have factors? I don't think so. No, so we'll have to use the calculator here and the minus b formula. And when we use the minus b formula, we get the first answer will be minus 3 plus root 13 over 2. And the second answer, of course, is minus 3 minus 13 over 2. And this is for u equals or u equals. Now remember, we're not looking for u, we're looking for x. So we have to replace the u with what it was earlier. Log 2x equals minus 3 plus root 13 over 2. And log 2x equals minus 3 minus root 13 over 2. So remember what log means. It says 2 to this power equals x. So we have x equals 2 to this power. And here we have x equals 2 to this power as well. Yeah. Which we can put in as a decimal. We don't have to though. 2 power minus 3. You have it, yeah? Let me just double check it. Minus 3 plus root 13 over 2. So this one is roughly 1.23. And then the second one is roughly 0.101. Are both answers acceptable? Yeah, because they're both positive. I'll give you one like this to try. And then I'll do it. So what I want you to try is this one. Log 4 9x plus 1 minus log 2 6x plus 2 equals minus 1. Oh, let me go. Yep. But I'm not seeing exactly what's different. Oh, you mean here?
Yeah.
Ah, yeah. These don't go together quite like this. This 2 and 3 will have to go to the power. Then they can combine.
Okay, yeah, I get it.
Yeah.
So then how would I finish it?
I don't think you really can. I think it'd be better doing the way I did, because it's going to end up being much messier.
Okay.
Yeah. Okay, you have this one? Now let's have a look at it. I cannot use... Are we looking? I cannot use the first rule of logs, or the second rule, because the bases are different. So the first thing I need to do is change the base. So if I use rule 5, I can change the base to whatever I want. So I'll change the base to base 2. But the price I pay for making that change of base is now I must divide by log base 2 of 4. Log base 2 equals minus 1. What is log 2 for? 2. So now we have a half log... Oh, actually the very first thing I should have said is when are they defined? Yeah. So let me just do that on the side. I need 9x plus 1 to be positive and 6x plus 2 to be positive. And 6x plus 2 to be positive. So x must be bigger than minus 1 over 9 and x must be bigger than minus 1 over 3. Therefore, x must be bigger than... What's the only way both could be true?
That makes it bigger than minus 1.
There's 0. There's minus 1 over 9. There's minus 1 over 3. I need x to be bigger than this and bigger than this. The only way both can be true is if it's bigger than this one. So I need my answer to be bigger than minus 1 over 9. Yeah? You don't seem happy with this. Okay? Alright. Right. Back to the question now. Right, so as I was saying, log 2, 4 is 2. So this is a half log 2, 9x plus 1 minus log 2, 6x plus 2 equals minus 1. Can I use the second rule now? No. Why not? Why can't I use the second rule? Because of the half. So what I can do is I can bring this up to the power. So this would be log 2, 9x plus 1 power a half minus log 2, 6x plus 2 equals minus 1. When I subtract, I divide using the second rule. So this will be log 2, 9x plus 1 power a half over 6x plus 2 equals minus 1. This is using the second rule of logs. Okay, now we just need to remember the definition of logs. If I can scroll down a little bit more. So remember what logs mean. They mean 2 to the power of minus 1 equals this. So 2 to the power of minus 1 equals all of this. And 2 to the power of minus 1 is 1 over 2. And power a half is square root. I'll cross multiply. So I get 6x plus 2 equals 2 square root 9x plus 1. Okay, any ideas on what I could do next?
Square both
I could square both sides. So if I square here, and then I square here, so on the left I'll get 36x squared plus 24x plus 4 equals 4 times 9x plus 1, because the square and the square root, they cancel each other. So now I get 36x squared plus 24x plus 4 equals 36x plus 4. So I get 36x squared. What's that? Minus 9, is it? No. Minus 12. Minus 12x. Oh, this is 0. Equals 0. Divide everything by 12.
Yeah, 3x.
3x squared minus x equals 0.
X.
Take out the x. So I have x bracket 3x minus 1 equals 0. So I get x equals 0 or x equals 1 over 3. Do I accept both answers?
No.
Yes?
Yeah.
Yes. Because remember, if I just zoom out, if I can see it here, I only required x to be bigger than minus 1 over 9, and both of these certainly are bigger than minus 1 over 9.
No.
So both answers we can take. Yeah. This is tricky, I know, but this is what you get in the exam. But this would be a section B question at least. So, I mean, this question might have something like 5 or 6 marks for it. Okay.
How many times has this question been in the exam?
I'd say it comes up maybe 1 in 3 exam papers. Yeah. Yes, check something. Okay, so just write this one down. Let me zoom out a little bit if you need to see more. Yes. This is log 2,4 in the denominator. Log 2,4 is 2.
Okay.
So this is all this over 2. So it's basically it's the same thing as divided by 2.
Alright.
Yeah.
Sure.
Okay, did you write this one down? Yeah. There's actually one more example that I think I skipped over this I want to do, but it's short, don't worry. I'll just check. Yeah, I didn't do it, so I want to do it. Okay, can you see? Yeah. So, just really quick example. 2e 2x minus 9ex plus 6 equals 0. What type of equation is this when you look at it? It's a quadratic, and what's the variable? Ex instead of x. Now if you try to factorize this, will you have a hard time? You will have a hard time because there's no factors. So if you use the formula here, we get x equals 9 plus root 33 over 4. 9 minus root 33 over 4. Nobody got my South Park reference, no? No, nobody watches South Park then. I said if you're going to try and solve this, you're going to have a hard time.
Okay,
Fine. I guess you guys don't have the internet, so okay, so we have 2 answers here. No, actually this isn't for x, sorry, this is for e power x. But how can I get x? How can I cancel the e? Yeah, so the answers will just be x equals log 6 plus root 33 over 4, or log 9 minus root 33 over 4. And that's it. Okay, so we just use the formula to get the 2 answers, but the 2 answers are for ex, and if we wanted for x to cancel the e, we use log then. So like I said, it was just a quick one. And again, this is if they want the answer exactly, you would leave it like this. The potential problem here, what might be a reason for rejecting one of the answers? Yeah, for example, if this one was minus, then when you calculate the log of it to cancel the e, you'll get no answer here. Now both of these are positive, so it's okay then. Yeah, but this would be a reason for rejecting one of the answers. Okay. Now what I'll do is I'll tell you your homework. ABC, and then yes. It's okay? Yeah. So, A, B, and C for the homework, and then what I'll do now is I'll give you the coursework. This is like a peek at the coursework. You don't have to start it just yet, because I haven't given you the date that it's due. So when I do give it to you, I'll probably give you the due date on our last class this week, which is Thursday. Yeah. So in Thursday I'll tell you when it's due, but as a minimum you'll have at least 2 weeks from after I tell you when it's due. Okay, so this is like a preview of it. Okay, you need me to leave this open? Right, well let me just hand this out. We'll just have a look at this together first. So homework is A, B, and C. So, huh? A, B, C from this one. Guys, come on, don't.
One more.
We're going to talk about this for a minute. And then we can have the three amigos at the back there. Thank you. Okay, can we all have a look at this together, okay? Can I close this? Yeah. Well, do you know what? I'll leave it open because it'll still be recording what I'm saying if you want to hear this later. So this coursework here, it might seem difficult at first when you first read it, but when you actually start doing it, it's okay, it's not too bad, and everybody will get to the answer in the end, okay? So it's just one of those things that seem more difficult at first than they are, but once you start doing it, it's okay. So on the front page, I'm just giving you some basic background for what this is about. The coursework is about recursive sequences, and it's broken into 3 tasks. So let's look at what I ask you to do in each task. So in the first task, this coursework is about recursive sequences. Each student will be provided with the first few terms of a sequence on Moodle. So when you go to Moodle, there'll be a link that says like data for coursework 1, something like this, data for CW1. If you click that, it will ask you for your student number. If you don't have your student number, you can use your date of birth. It doesn't matter, you can use your student number or your date of birth. When you enter your student number or date of birth, it will make a list of numbers for you. This is going to be different for each student, so each student will get their own sequence of numbers, okay? Each student will get their own sequence. You've studied recursive sequence in class, okay, so what we're going to look at in particular, recursive sequences that depend on the last 2 terms. So we're looking at a recursive sequence that depends on the last term and the previous term, which we've seen a little bit in class about that. I think we were talking about in the tutorial maybe 2 weeks ago or even last week. Yeah. So what have we to do? Part A for 6 marks, and the total is 50 marks, to write an introduction explaining recursive sequences. Part B is then the first thing you have to calculate. You have been given the first 6 terms on Moodle, and the formula is below. Un equals A un minus 1 plus B un minus 2. Find the value of A and B. So, can anybody think of how we could find the A and the B? So, just remember, I've given you the first 6 numbers. So, let's imagine, okay, this is not a real example, but let's just imagine the first 6 numbers. Oh, well, actually, it could be 1, 1, 2, 3, and 5. Is that 6 of them? 8. Now, I know this is a simple one that we did in class. So, your numbers could be something like 1 over 4 minus 1, whatever. But that doesn't change what you have to do. So any ideas on how we could find the A and the B? And the formula is un equals A un minus 1 plus B un minus 2. Well, tell me this. How many things do we need to find in total? 2. So we could try to make 2 equations with A and B in them. What could be an equation I could make with A and B here? What is this here? The first term, isn't it? This one? Second term, this one? Third term. So tell me, using this formula, the third term, which is 2, that should equal A times 1, yeah, plus B times 1. Because the formula says the next term is A times the last term plus B times the term before that. For example, the 8, what should the 8 equal? 5A plus 3B. So you realise, do you have enough information to find the A and the B? Yeah, so you can find the A and the B. Then what you need to do in part C is use your formula to make the table, but go up to the 10th term. So here we have only 6, but you can use the table to go up to 10 once you have the formula. So task 1, I think you have enough to do task 1. You can see how to do it. Then in task 2 it gets a little bit trickier. So I start off by giving you another formula you could use for un. I could say un as a direct formula is equal to c e power lambda n. Now don't worry, the c and the lambda is just constants. You could have called it a, e, b, x if you wanted to. But I didn't want to use a and b because I already used a and b in the first part. So here what you're doing is considering the formula in a different form. Instead of un equals this, we can say un equals this. Then what I say in part B is substitute this into this here and then try to solve for c and lambda. So I don't want to go into the details now because it doesn't really make sense to talk about this until you see what's happening, but you have enough to start this anyways, and when you get stuck in, if you hit problems you can come see me. So in task B, what you're trying to do is basically find the c and the lambda. More difficult than finding the a and the b. Now, in task C, so basically at the end of task 1 you should have found the a and the b. At the end of task 2 you should have found the c and the lambda. Lambda, yes. Lambda.
The x, y.
Then in task 3, what I ask you to do is the reverse of something that you did in class today actually. So let's imagine we know the c and the lambda. Let's just pretend it was, for example, 2e, let's just say 3x, for example. What I want you to do here is to rewrite this in the form of a or n minus 1. So you can use what you learned today to try and help you rewrite something like this into this form. So what we did was we wrote something into this form, but using the same techniques you can easily rewrite it into this form. A number to the power of n minus, in this case it'd be x minus 1 if that's an x there. So it's actually easier to do it from here to here than what I did in class, so it shouldn't cause you too much trouble. And the reason for doing that is because what type of sequence is this? Geometric. So once it's geometric, you can do the very last thing, which is to find Sn. So basically your goal in this coursework is you start with a sequence like 1, 1, 2, 3, 5, 8. Is this sequence AP? No. Is it GP? No. It's recursive. But through this whole assignment, what you'll be able to do is to take this sequence and rewrite it into, in fact, 2 GP sequences. And once you can rewrite it into a GP sequence, then you can use the formula Sn. So if I was to ask you to calculate the sum here, that would be impossible for you to do because you have no formulas for doing that, right? But if you can rewrite it into something like an AP or a GP, then you can calculate the sum. So there is a lot here. It will take you some time to do, but the good thing is the students who work on it, they always get to the answer at the end and they always get good marks for it. So it's not an impossible coursework. It just, right now it seems much more difficult than it is, but once you start doing it you realise it's not too bad, okay? Now, some things to note. I want this typed up in Word, of course, and you'll have 2 weeks to do it. You can use Excel for it, because for some of the questions I ask you to make a graph, so you can do the graph in Excel. And if you have any questions, please show me what you've done, and then I can give you a tip or a hint on what to do next then if you get stuck. That's the most important thing, okay? Yeah. Oh yeah, I don't need to see every single workings like this plus this equals this. But just like make it clear what it is that you're doing. But you don't need to show me like, and then this plus this made this, and you know. So you don't need to give me exact detailed workings, but I do want to see what steps you're taking.